Much better. Great. Thank you. OK, so let's go on, guys. We will also have a big demo somewhere in the middle here to tie these concepts together. So we'll show you the abstract concepts, what the bits and pieces are, and then we'll show the whole thing together. Before I launch into the presentation, I want to mention one thing. And this is really made possible by the infrastructure as a service offerings we have in the platform now. We now have a lot more orthogonal, or if you will, independent concepts in Azure, which you can put and mix and match to meet your solution. So on the one hand, it's a lot more powerful than before. You can really put solutions together. On the other hand, it's actually complex. So we also have a lot of cookbooks and white papers and examples of how things are put together. And the demo is a good example of that. OK? Some basics first. This is maybe the only high-level-ish slide in the presentation. Please note that with this cloud stuff, and for some of you who have been doing this thing for a while, there's been a shift here in focus when it comes to availability and durability and so forth. In classical systems, the ones that many of us, I speak for myself, sort of learned and used in the past, the focus was always on reducing the time between failures, if you want. Okay, you want to have increasing the time, I'm sorry. You want to have the mean time between failures to be very large. What this means is that you made your data center, you made your machines, your software as highly available as possible. You use clustering. You use 5-9 data centers. You did gold-plated systems. And the idea was very simple. Keep your machines, keep your mainframe, if you will. That's what mainframes do. Always up and running. It really meant expensive systems. It also, frankly, in practice meant that recovery can be long. Because the expectation was failures almost never happen. If they happen, oh, well, we'll figure it out. This cloud business we're in nowadays is quite different. The focus in the cloud really is mean time to restore or mean time to recovery. In other words, failures are expected. We have very large systems, basically built out of less expensive, very homogeneous systems like. They're not gold-plated. If you want a cloud system which is gold-plated, you're going to be paying for it, and nobody wants to pay for that. Yet the expectation is very high. Services are supposed to be always up and run. Your phone expects some services in the cloud. They have to be always up and running. So individual failures are expected. They can happen, and they do happen. But the applications themselves have to be able to recover very quickly from these things. This also implies one more thing, guys. And if you know this thing, if you've been running or managing services in the cloud, the model you use to manage the application to recover from failures is different. You really have to, when something goes wrong, to emphasize, I want to get back capacity up and running. You want to get back to some recovery and keep moving. Maybe not the full capacity, not the full functionality, but you have to build in your application enough support to be up and running all the time. Okay? So that shift is important, guys, in thinking. And when I show you the laundry list of here's a mechanism, here's a mechanism, keep that in mind, how you can put them together to end up with the story. OK, let's go some specifics. Let's talk first about Azure VMs and networking and how we can put some solutions together to make them highly available. As you may know, and if you've been in some of the Azure talks, you've seen slides similar to this one, the basic building block for virtual machines, for infrastructure as service virtual machines in Azure, is to put them together in so-called availability sets. An availability set basically is a way to say, this tier of my application, in this example, maybe a number of IIS instances or SQL instances, are together a tier of my app. And that tier, I want it to be highly available, such that if a single failure happens, or if we are updating the infrastructure, we don't bring down the whole thing. So in this example, we typically, behind the scene, when you tell us these things are in an availability set, we know that you care about them as a unit. And we typically, behind the scene, put them across so-called fault domains, which in practice means across racks in our data centers. And moreover, when we are doing any maintenance for our software, we are cognizant where things have been laid out in the topology of the infrastructure. That's all invisible to you, by the way. You just tell us that these SQL instances are in an availability set. I will make sure that For example, if this rack on the right-hand side went down for some reason, we make sure we don't update the one on the left-hand side until the right-hand side instance is up and running again. It's actually required, if you read the fine print, if you want to be within SLA, that your instances have to be in availability sets. In other words, our SLA, it's supposed, the best SLA, if you will, is to deploy multiple instances in the system. Now, this is just a building block. Everything else holds true. So you want to make sure that if a failure happens, your instances can be recovered quickly. You need to worry about your data, which I'll tell you more about in a second as well. But availability sets are your friend. Use them, please. Now, we have a number of technologies in the platform, and as we'll show you the demo on part of this thing in a second, that aid in having hybrid solutions. So I mentioned availability sets within a DC, within a region, if you will, but you typically want to build solutions that crosses regions. You may want to cross between on-premises and the cloud, or between a cloud and a cloud, if you will. And there are multiple layers. I'll touch on a number of them in a second. And in this particular slide, at the highest level, you need to be able to move data around. Or we have multiple solutions for those, to back up data from one place to the other place, or restore them. We also have a layer where if you are writing an application from scratch, or you have the ability to recompile the application, to do messaging at the application level. Service bus is an example of that, and there are other talks on the subject. This is durable queues, durable messaging across locations. At the bottom of the stack, we have connectivity solutions that we collectively call them, if you will, Windows Azure Connect, which is the bottom two parts. They're the key technology to connect these systems securely and seamlessly. These are VPNs on steroids, guys. It's just IPsec, but managed by us, if you will. You have the bottom one where you have secure site-to-site connectivity. I'll show you slides on this in a second. And we have the new secure point-to-site connectivity, which is very easy to use as well. And I'll tell you about them in a second as well. These are important building blocks for any hybrid solution you want to build between one place and the other place. So let's talk about site-to-site and then a point-to-site, if you will. The key point here is that this is a mechanism to enable you to extend your infrastructure from your existing on-premises infrastructure and join it seamlessly in a network sense with your network in Windows Azure. And the way it works is really straightforward. For site-to-site, you need to have an on-premises router-based VPN. We have a number of vendors that we support, and you can actually use software solutions. You can then basically connect your subnets with our on-premises to your remote subnets in Windows Azure using virtual net. And you have a lot of control. And Ganesh will show you some of the knobs you can use in there. You can choose your IP subnet addresses, how they're configured, and so forth. This is the most powerful mechanism, and you can use it to do things like make sure your network looks the same as if in the cloud. Modulo physics, of course. There's always latency, of course. But beyond that, it will look as if you're running on the same network. What we also have now is the ability to have point-to-site VPNs, which is great for things like dev and test scenarios. With your laptop, you can basically, using your VPN client, connect to the same networks or different networks. And it's great if you're doing development, debugging, monitoring. Having used it myself, it's such a nice experience, as if you're living in the cloud itself. You're not going through the public, public endpoints and the like. You're going through basically your backend network. So in summary, this virtual networks extend your data center network, or the part of it you want, of course, to the cloud. You can create subnets, choose your IP addresses if you want to. You can bring your own DNS. That can be very important in some scenarios. And you can do things like join your VMs to your domains. And we have cookbooks, and we have examples of all of these things for you. There are different patterns, different applications you can use with these things. But the basic pattern is shown in this picture. You have an internet-facing connection to your service. That's typically where devices and where your customers and clients are talking to you through public IP addresses. And you have a backend, how your network in Windows Azure is, if you will, joined or connected to your on-premises network. And where do you place your application? That different tiers of the app depends on your scenario. You may have a scenario, for example, where you want to do some bursting scenario, where your app is mostly living on premises, and you want to, because of seasonal reasons or your customer want more demand, to place part of it in the cloud. Which part? It's really up to you, to be honest. You can have a scenario where you put your web front ends that can burst from local to the cloud. Or you can have a different way around, have your data in the cloud. When I tell you more about the backup solutions and the like, this hopefully will become clearer, which way you want to use it and so forth. But it's, the net point is that it's the power is with you. We don't stop you from doing whatever you want to in this space. You can put all your data in the cloud, join it back on premises, vice versa, whatever is needed for you. Now, let's show you something concrete. And Ganesh will show you a demo in a second. And just I want to set up very quickly for you. We'll show you a demo and a whole setup that demonstrates the concepts I told you so far and shows you how you can set up a highly available and disaster-tolerant SharePoint system across the continent. And we're going to do it using site-to-site VPNs and some other technologies as well. Ganesh?
Thanks, Yusuf. Hey, everyone. My name is Ganesh Srinivasan. I'm a program manager in Yusuf's team, and I work on virtual networks quite a bit. So I'm going to be showing you a few things over the course of this demo. Before I get started, I wanted to ask you how many of you have played around with Azure in the past and know the platform to a certain extent? That's great. And how many of you have actually played around with virtual networks in the past? Oh, that's great. So hopefully you're going to make my life extremely easy with this demo. What I'm going to be showing you in the course of a demo is kind of, Yusuf talked about a few concepts in his slides. I wanted to show you what it really means in terms of when you create an application and how you create an application, and then show you an example of how you could use site-to-site connectivity for DR and other purposes, high availability and disaster recovery. So this is the Windows Azure portal. You can log into it, and when you log into it, you get to see all the services that are listed in Windows Azure. And in this particular case, I have a list of about 25 virtual machines running in my subscription. Now, what it actually means is that I actually have two highly available SharePoint farms that I have deployed in two different data centers in Azure. So I picked a data center in US East and another data center in US West. I created a virtual network in each of those. So if you look at the slide that Yusuf was just showing, there are two SharePoint farms that are basically in two different corners of the country, and they're connected to my premises, which I simulated in my office. I have a set of machines that simulate my premises, where I actually have F5 devices as my VPN device, plus we also use the F5 device as a load balancer to load balance between these services that are distributed in these two regions. So let's look at first how we make each application or each tier or each service highly available. And you do that by putting each tier in an availability set. As Yusuf talked about it, an availability set is a soft concept that we introduced where if you place multiple virtual machines or services within a single availability set, we actually distribute these machines across different fault and update domains. So at any given point in time, we ensure that at least one instance is available so that your service is up and running all the time. And when you create your virtual machine, you have the option of actually placing them in an availability set. So if you created a virtual machine from gallery and click through the wizard to create a virtual machine, the last screen in the create virtual machine option will ask you to specify the availability set. You can choose to specify it at that point in time. If not, you can always come back and add the virtual machine to an availability set. And that just groups virtual machines that do similar functionalities together and place them appropriately. So in this case, I actually have two web front-end virtual machines for my SQL front-end, and I've chosen to place them in an availability set. And if you look at another tier, which here I'm going to show you my SQL database tier, I have a highly available SQL cluster. Yusuf is going to spend some time talking about SQL HA and all the solutions we have in the platform. We have created a SQL HA cluster that's running in Azure, and that's what you see these 3 instances doing here. And they are in an availability set. So when you add anything to an availability set, you'd be able to see all the other virtual machines that are part of the same availability set. So that's one concept, place these virtual machines in an availability set. The other important thing about high availability in disaster recovery is the fact that you want to make sure that your data is stored appropriately and is highly available and is secure enough when there is a disaster that you can recover all the data fully. So when we made the decision to create virtual machines, we decided that we'd use our storage stack to store the virtual, the VHDs of your virtual machines, be it the OS or the data disks, because high availability is built into our platform. And if you actually look at our storage accounts, and you click on configure, you'd be able to see the fact that you could enable or disable geo-replication. This storage account is something that I created in the US East region. That's why I called it TechEd USE. And you can see that the secondary region for it is automatically picked. There's a pair for every region in terms of storage. So we automatically picked US West as the DR site, and we constantly replicate whatever you put into storage into that storage account. And Yusuf will talk more about what it brings to you from, and how it helps you build a highly available application. So if you can choose to disable it, but having it enabled gives you that protection that, at any given point in time, data loss is minimal or you can avoid data loss. So now with that, let's look at networking. As Yusuf just mentioned previously, you could create virtual networks. These are essentially IP address pools that you place in different regions that you specify. These are all private IP address pools, and you can have them connected back to your premises using a site-to-site VPN. Earlier this week, we announced support for F5, Citrix, and WatchGuard devices. You can use them as site-to-site VPN devices, and devices like F5 as your load balancer as well, in addition to using them as VPN devices. So for this demo, I'm going to actually show you how we put together this. And in addition to the fact that you can get DR across sites, one common thing is that you're using a VPN to connect between your premises and the cloud. And we want to make sure that the VPN device is also highly available on the on-premises side. So on the Azure side, when you have a virtual network with a virtual network gateway, we always make sure that we have 2 instances dedicated for every virtual network, 2 instances of the gateway running in active-passive mode. So if we were to detect any failures in the system or in our active gateway, we automatically fail over to the passive one. And that takes roughly about 30 seconds for us to fail over from active to passive on our side. And one of the common asks for us has been, can you support some sort of a router redundancy protocol or support redundant tunnels or some way to make sure that the VPN device on the premises side is not the single point of failure? And our partners from F5 have come up with a great solution where with just a single tunnel, you can actually create a highly available cluster of F5s and actually fail over between them. We'll show that as well as part of the demo. So for the sake of the demo, I'm actually going to log into my office. We have 2 F5s that are configured as a cluster, and they are the gateways that have connectivity to the 2 virtual networks, one in US East and one in US West. We have a third F5 that's behind these 2 that's actually acting as a load balancer for traffic that's facing the intranet. So in this particular case, our primary scenario is actually exposing a SharePoint site that's hosted in Azure as an intranet site to your corporate network. So I'm going to log into this and show you the configuration. So I'm logged into the F5 device, and I've actually configured a load balanced endpoint. And if you look at it, I'm going to load balance my SharePoint front end. I picked an IP address 10.1.0.10. Sorry. I don't know why it does that, but I want to just zoom it and show you. So 10.1.0.10 is the load balanced IP address that I wanted to get, and I added my 4 front ends to this pool list where I have 2 front ends in US East and 2 front ends in US West that are load balanced. So if I connect to the SharePoint farm using the private IP address, I should be able to get a SharePoint site. So let's try that. I have a test machine that's running on this Hyper-V box. I'm going to launch a browser. And I'm connecting to the SharePoint farm. So right now it's going through the load balancer. It's going to pick the best dip according to whatever policy we've configured, and it's going to connect to that front end through this VPN tunnel. So this setup is set up in such a way that there are 2 data centers, both connecting to my office across the country in Redmond, and we are connected to a machine sitting there. So it's going to take a few extra seconds because of the path that the packets trace before it appears in the screen. So it's load balanced and it's typically highly available. So even if one of the sites goes down, you will still be able to connect and have this SharePoint farm running. So it's for some reason taking an extraordinarily long time today to show up, but here it is. So you have the SharePoint farm running, and I have all my 4 sites, 4 front ends up and running. Let's say for some reason connectivity to my US West data center actually went down, and I could simulate that by actually disabling the front ends on the US West side from my load balancer. So it looks like the site actually went down. And if I was to refresh my browser here, I would still have connectivity to my SharePoint farm, and I would be able to access the same website, and I should be able to do whatever I want to do with that SharePoint farm. So you can see that the page is still highly available, and I can do whatever I want with that SharePoint farm. I can do the same thing. I can fail over to the other front ends, and wherever I had been in the previous SharePoint farm, the new SharePoint farm will automatically take over and do everything. If you make sure that your databases are synchronized and your identity active directories are synchronized, everything gets synchronized across the 2 sites. So you have a highly available SharePoint farm that you can run your business on. So this is just to illustrate the fact that if you have a multi-tier application, you can get high availability for the intranet-facing site. We also have another solution called Traffic Manager if you want to build a highly available application that's facing the internet. So now let's get to the interesting part. So we have 2 VPN devices that are in active passive configuration that are on the premises side. So I have 2 virtual, these 2 F5 appliances. If you look at it at the top right corner, one of them is in active mode, and the active passive mode. So this is online, and the second one is in standby mode. So we can go and force this device to go into standby mode. So what that does is actually assumes that we are simulating the fact that this VPN device has actually gone down, and the other one has to take over. So we forced it to standby mode, and you can see that the next one is automatically gone onto active mode. So they did a great job in causing this VPN device to fail over near instantaneously. But the devices have failed over. There is going to be a short period of time for which connectivity is going to be down, and it's going to be of the order of a few minutes at this point in time. We're working to reduce that to a few seconds. But till that happens, in a matter of a few minutes, the entire tunnel would have failed over from one VPN device to another, and you have full connectivity back to the 2 regions that you have already configured for the virtual network. So if you configure one F5 and mirror them, it's extremely easy for you to get all these things up and running beautifully. So you can build highly available applications in Azure. take advantage of the fact that we have presence in a lot of regions and build a highly available application. So I'll now hand it back to Yusuf, who's going to talk to you more about a lot of new concepts that we have in the platform and a lot of tips on how you can build a highly available service running in Azure.
Thanks, Ganesh. This is great. So behind the covers, here, we have a number of technologies which I will mention today, right now. So let's switch to storage, talk about storage, databases, and some of the management aspects to put the whole thing together. And some of this you guys may be familiar with because we had some of these technologies from the beginning. Now, when I say storage, I'm referring to the basic infrastructure we have for blobs, tables, and virtual machine disks themselves, the disks you can attach to VMs. All these are stored in our basic storage system. The system itself is highly available and durable and disaster tolerant. Let me explain. It's highly available because we have actually multiple instances of servers behind the scene that serves your data. It's durable. All your writes end up being written 3 times within the same DC. And it's disaster tolerant, if you will, because we also have remote geo-replication, which I'll mention in a second. This is one of the first pieces we had in the platform for many years from now. So it's quite, if you will, we had a lot of miles on it, if you will. Let's put it this way. And everything in the system is built over the storage system. And this is the same thing you can program directly against using REST APIs, or you can take a disk drive and just mount it, if you will, use it. And everything is shared or stored in the same infrastructure. We have 3 copies and so forth. Now, as Ganesh showed you in the demo, you can make sure that all your data that goes in a given location is geo-replicated to a remote location. This is a great feature, guys, which is built into the platform. The replication is asynchronous. It's not synchronous, guys. Okay? So eventually, your writes will make it to a remote location. Typically, it takes a few minutes, but it's a function of how much you're writing, to be honest. And we typically pair our data centers or subregions with a remote subregion. So unless you take that thing off in the portal, your writes end up being replicated remotely to a remote region, automatically by the platform. Do note there are a few restrictions here. You cannot get to a remote copy unless a disaster happens. And you cannot control the failover between these 2 locations. Eventually, you will remove these restrictions, but for now, this is truly a DR last resort solution. We test this all the time, and knock on wood, we never had to actually use it in production. So the idea here is to give you insurance, and to give us insurance, if you will, that your writes are not only written locally, but they are asynchronously replicated a long distance to a different data center. It's typically a few hundred miles, plus or minus. Now, not only your blobs and tables are written this way, but also your disk drives, your virtual machine disks themselves, are stored in the same storage system. So perhaps unlike other competitors who have a different system for their VMs and with a different SLA, what have you, here the actual writes end up going through the same highly available, highly durable, and geo-replicated system, using the same semantics, really. Yeah. Now, in addition to the base system, we also have other options available to you. So if you're familiar with Store Simple, it's an appliance you can buy from Microsoft. It can extend your Azure storage. You can extend your on-premises storage to Azure. It's really a box you drop on your on-premises. It shows you a bunch of iSCSI disk drives, basically. And it does all sorts of things for you. So typically, without something like Store Simple, you would do something like the first row in this table. You have some volume of data. You may do some local snapshot, depending on technology you have in-house. Do some replication, maybe go to a virtual tape. Eventually, maybe give it to a tape and put the tape in a truck somewhere to store it somewhere else. There are still legitimate uses for this scenario, by the way. So if you have it and you need it for compliance or otherwise, stick with it. But with Store Simple, you can really simplify things quite a bit. You can take your primary volume on premises and end up with a number of features automatically done for you. Basically, your data will make it automatically to the cloud. Your hot data will still be cached locally. And things like functionalities for backup and restoring the stuff are built in the base system. And I'll give you one scenario in a second. It's really very easy to set up. I mean, I can emphasize this particular point. Most of your apps will not even know that you are storing this almost infinite storage out there, because you're doing local caching and using Azure to get the data move up in the front, up there, if you will. And you can do very fast restore from that. So one way you can use Store Simple is as your DR story, if you will, for your data. And the setup is very simple. You have Azure in the cloud, and you have some storage accounts, which you acquire through a portal through a normal means. Okay? You configure your Store Simple to have those credentials to your storage accounts in the cloud. And then during normal production, if you will, you connect as many services you want to the cloud through Store Simple, which is then backing up your data to the cloud. So far, so good. This is basically effectively a backup scenario. If your data center goes down for some reason, a disaster, a fire, whatever you want to, the data you have in the cloud can be reconnected, if you will. It can be recovered very quickly to a remote solution, to a different Store Simple appliance. And if you take care of the app itself, your data will then be available to your apps in a remote location. This is a simple explanation of otherwise a very complex scenario. By dropping a couple of appliances in two different data centers, creating a storage account or two in the cloud, and configuring it, you get a very high level of insurance here. Moreover, the data that makes it to the cloud through your Store Simple appliance itself is stored in Windows Azure storage, which, as I mentioned, itself is highly replicated within a DC and geo-replicated. You have a lot of redundancy in this system. And some of us are in businesses where paranoia is important. And if you're paranoid about your data, do something like this, please. By the way, Store Simple is a lot more things as well. So I think it's a talk or two on the subject, so please take a look at it. There are other options you have, and some of these you can mix and match. You have another option to store your data in the cloud. There's a service called Windows Azure Backup Service in the cloud. Again, is built on Azure. If you're a System Center customer and you have it deployed in your infrastructure, there's now a data protection manager part of System Center. And you can use it to configure a backup of your data from your on-premises data. And it's a very easy way a very powerful way to take your data you have on-premises in your Windows Server and back them up to Windows Azure and to restore them back from Windows Azure. And again, same as before. Once the bits make it to Windows Azure itself, it's highly durable and replicate in the cloud as well. You can also take Windows Server 2012 and directly write stuff into Windows Azure Backup, by the way. But if you have a complex setup and the like, System Center makes the whole process much easier to automate and to aggregate across a large number of servers. Yes, please, question. Is it possible to encrypt data on-premise? If you do it, you have to do it yourself. At the moment, we don't have a mechanism in Azure itself to encrypt it on your behalf. But it's actually a common question we get as well. Eventually, if we do it, the only question we have is to make sure that key management is easy. That's a trick with all these encryption schemes. You can encrypt them, but if you lose the key, you lose the data. So at the moment, it's up to you, to be honest. And we have customers who are under some compliance regimes like HIPAA and otherwise, who encrypt themselves before they put them up in the cloud. Ourselves don't care what the bits are, but in that case, the key management becomes your responsibility. Yeah.
What's the difference between Windows Azure Backup, like that I've used in Server 2012 Essentials, and System Center Data Protection?
If you have one machine or two machines to manage yourself, you can just use Windows Server to Windows Azure Backup and you're done. If you have a farm of machines or a very complex setup, System Center makes it much easier to aggregate and manage and keep track of things and restore en masse. So it's a management solution, to be honest.
Okay. I know with Essentials, I know I got like 300 gigs, I think. With Data Protection Manager, do you get, what is the...
I don't know, actually, we can get to you offline, but it's the intention with data protection manager, they get the full power, if you will, which is, it's very standard, if you will. You have basic stuff in the system, and System Center makes it much easier to manage with you. But I can get you offline with the actual details in there. But all this stuff is here and now. There's no future stuff here. This stuff exists today. So again, before I move on, this shows you the power of having on-premises infrastructure, Windows Server and System Center, coupling it with Windows Azure and the durability and availability that one gives you as well. In a sense, the sum of the parts here is more than what each one can do by itself. Okay, I'm moving quickly, guys. So we talked about virtual machines. We talked about networking, connecting them on-premise in the cloud. We talked about the basic storage. Let's talk about databases now. Specifically, what infrastructure as a service allows you to do now in Windows Azure with SQL Server. So with infrastructure as a service support in Windows Azure, you can now use SQL Server 2012 with SQL availability groups. What this means in this particular example is you can have a complete SQL cluster with domain controller, if you want to, running in the cloud, with replication, synchronous commit between your primary and secondaries, to give you a very highly available SQL solution in Azure. And moreover, we have this documented and white papers and the whole setup. We make it very easy for you to make this thing actually work. And there are many ways you can actually use this thing, just as a way to take what you currently would have had on-premises and run them in the cloud, as a backup to your on-premises, or vice versa, as a DR location for your cloud on-premise or whatever you want to, basically. Either way is fine. And you basically have the full power of SQL Server in the cloud now. Now, this is not all. So again, this picture is about make it highly available using SQL availability groups. You can also have a different scenario where in the bottom part, you have the on-premises network, which is running on-premises availability groups of SQL Server with replication in your domain controller. You can, by creating a virtual network with this VPN tunnel shows in the picture, the stuff Ganesh showed you, you can then run one of your secondary replicas asynchronously in the cloud as well. So what you get here is that highly available system on-premises, maybe with whatever backup solution you want to do on-premises. But in addition, you get asynchronous replication to a secondary running in the cloud itself. So if something goes wrong to your on-premises system, you can go back to your replica in the cloud and restore from it. And if you do your job right, you can restore it somewhere else as well if you wanted to. Yes?
And is that usually just a one-way to the cloud, since the cost of bringing data out of the cloud is so high?
What do you mean one way?
Is the primary replica on-premise just pushing the data to secondary replica?
In this scenario, the way this is portrayed is that we're just pushing it out, if you will. But you have other possibilities to configure the stuff. The only limitation the main limitation we have today is that you cannot set up this thing between two clouds. So today, we don't have availability groups running across two regions, okay, which I was going to mention later on. But otherwise, you have a lot of power to configure it between on-premises and a given Azure region in the cloud.
Can you do it without the VPN tunnel?
I think you need a VPN tunnel for this one, right, Ganesh? For the availability groups across, we the VNet.
You don't need
VNet. No need for a VNet.
the availability groups in SQL or availability sets?
Groups.
Availability groups, I take that back. We need a VNet
I thought
because
so.
you need domain controller.
Yeah. So domain controllers are needed. I need a VPN connection for that. But the VNet setup is quite straightforward, to be honest. Question?
Yeah, I'd like to make a comment. Is really the only reason why you need the VNet or whatever for the firewall to be open? I've done Azure East and Azure West replications, so you can't do that. We have this left open firewall, so you wouldn't want to do that. But the point is, limitation is not a technical one. It's just that this is not recommended.
At the moment, we don't recommend it.
Yeah,
There's some more work on our side, to be honest.
but it's kind of important to understand that it's just servers out there.
Yep.
They do work.
I want to emphasize this particular point, guys. I mean, as I mentioned, what we have done, if you've been watching this project, what we've done the last year is we're making that last sentence true, just servers. Just what you're used to, it works in the cloud. They usually fine print here and there, to be honest, but that's basically it. Yeah.
So for the simple always on, how are you getting around the server name and cluster? Are you, your application is able to switch over to the how can you get around that?
I'm not sure the question, to be honest.
So I was looking for that, how you're getting around the cluster name, the lack of cluster
Can we take it offline? We're going to share the answer.
I can explain that later.
Yeah. We have at least one talk on the subject, by the way, as well.
There's actually a talk later today that talks about SQL high availability.
We're very happy with the stuff, to be honest, guys. One customer will be running it for a while before we shipped, actually. Other options we have, and again, this comes with the fact that it's just SQL, if you will. This is a simple thing. You can be running SQL Server on premises and using SQL Server Management Studio, just do your basic backups to SQL storage. You just give it the URL, give it the storage account, and you go. And again, very consistent with what I've said so far. Things being written to a cloud, end up being in our storage system, in a blob, durable, geo-replicated. And then if you need to, you can easily restore it. Now, you can restore it in multiple ways. You can restore it to your own premises again. You can restore it to a remote data center, for example, if you have multiple DCs. Or if you set it up correctly, you can restore it into a VM running SQL in the cloud itself. So it's a way to get backup continuously in the cloud. And if your on-premises system is offline for whatever reason, you can arrange for SQL itself to be restarted, in the cloud using the data, and you restore from there as well. Again, lots of power for you here. Yes, question?
That's compressed using SQL Server, right? Backups. It's compressed, but it's not no mechanism that makes that better as far as moving that data into Azure.
Better than?
Well, I mean, it's just you're going over a link to Azure.
Yes.
So it's not global.
There are other considerations of how much bandwidth you may need to go up there and so forth. Yeah, this is true. Please note, in all these systems, and this is independent of Azure versus our competition, or even your own DCs, physics are just physics. So there's a point beyond which latency is an issue. Bandwidth is something eventually, hopefully, we'll also be able to address directly. The power of these solutions, by the way, is that twofold. I'm repeating myself here. Is you have lots of options now to put them together. And when you combine things like the ability to start a VM in the cloud, running SQL itself, or restoring the data, that restoration step can be quite fast, by the way. Because you don't have to ship back the data all the way back on premises. You have them right in the cloud, literally within the same DC, if you want. Yes?
I have one other.
Please.
So with this Store Simple device, that does throttle to Azure, correct? It does kind of
I'm sorry, the noise behind me making it hard to...
the Store Simple device does kind of throttle to Azure, doesn't it? So, like if you backed up to the Store Simple device, then it would
Yes,
take it off-site in a better way.
it does. It does own intelligence, if you want. Yep. Yep. So simple, by the way, its name is quite truthful. It's actually very simple to do some complex stuff. Okay, let's talk about management, and then we'll wrap up, okay? So in management, if you have a system center, there are some options for you in there to help you manage these systems. And this is a complex slide I'll go through quickly, but you can set up a system center and be able to do some configuration of your systems, if you will, and deploy them to multiple locations. You can deploy them to local systems. You can deploy them to Azure. Actually, you can deploy them to a bunch of service providers as well. And what it does, actually, a couple of things for you. It helps you with the aggregation of monitoring and operation of all your locations, be they in Azure, non-Azure, on-premises. And also, it gives you a very basic, but nonetheless useful, role-based access control system. As you probably know, guys, today in Azure, we don't really have a proper RBAC system yet. In this system, with App Controller in particular, you can join it to your local domain controller, and have a certain amount of rollback access control. It's not full-fledged, but it actually works. So your credentials end up being stored in your app controller, and from there on, you have for your multiple administrators a basic RBAC system to get to the cloud as well. We will expand on this. I'm showing you this thing to give you a glimpse of how things will become, okay? How they are today and how hopefully it will increase in the future. Now, if you want full power, we have PowerShell, of course. For those of you who have been watching Azure for a while, many, many years ago, we used to have a few PowerShell command written by one guy on the side, by the way. This is a full project now. We are committed to make all our functionality available full class through PowerShell. Few categories: basic automation for managing the VMs, doing all the business where you have to modify the VMs and their life cycle. You can do it through PowerShell now. The portal experience that Ganesh showed you for virtual network is available through PowerShell as well. You can script it. Similarly, for lots of the configuration aspects, and of course, all the storage aspects as well. And you'll see a lot more coming here as well. Behind the scene, we build much of this thing over the same set of APIs that the portal is using as well. So we are committed to parity between the portal and PowerShell. There's some small discrepancies today. We'll close them. But you can be able to script anything you want to. And if you script something, you'll see it in a portal and vice versa. Yeah. We also have third parties you can use our system. And please note, I'm just giving you all the laundry list categories, if you will. For example, we have partnered with RiseScale. RiseScale is a management vendor that supports Azure, EC2, a bunch of other cloud systems. And it gives you a number of ways to get your applications configured and managed and deployed across cloud providers, ours and our competitors, by the way. It's not for everybody, but if you are in that ecosystem, it makes perfect sense. And we have things like one-click cloud backup and so on and so forth. So if you're interested, check their website. You see lots of collateral between us and them, and we have a close collaboration with them, along other third parties, by the way. Just mentioning them, like we mentioned our F5 partners as well. We're trying to be very partner-friendly because we believe the ecosystem has to basically increase and be bigger, and customers will decide what the best solutions out there for their solution. So that's one example of a third-party solution. Let me mention a couple of limitations, and we will end up quickly. So as I mentioned, for the storage system today, customers cannot initiate the storage geofailover I mentioned earlier. So it's ultimately used as a disaster recovery insurance if a data center is unavailable for a long time. We test this all the time, guys. However, and luckily, we never actually had to use it in production. Because if you have to use it in production, we have to declare a disaster, flip the whole system off, and it's complicated. Eventually, we'll give you more knobs here and control to have this control. But for now, it's basically an insurance policy. And as I mentioned, I think earlier, you cannot read the remote copy, neither. Okay. Eventually, hopefully, this will go away as well. That's important in some cases. There's some compliance regimes which requires you to show that your remote copy is readable. Today, you have to trust us. Okay? We'll fix that. Second important point is, I showed you a number of scenarios where there's a part of the scenario is eventually you want to start a VM in the cloud for a DR activity. You're restoring your snapshot SQL into a SQL VM and so forth. The only way to guarantee that the capacity is available after a disaster, you have to reserve it in advance. Okay? And the way to reserve it, you have to have a VM up and running and doing something. Based on your business needs, you don't have to reserve the same amount of capacity you have on premises or the same capacity you have for production. Look at your application portfolio, decide what subset must be up and running after the DR event, and decide how much capacity you need. And for the important apps, you need to have the capacity up and running, reserved, doing something, doing nothing, but it has to be reserved. And I'm telling you this, guys, because if we ever have a DR event, God help us, we never had one, I'm sure everybody will want to go and get some VMs right away. The only way I can guarantee you're going to get your VM is you have it already. Okay? Lastly, we discussed this point very briefly. Today, we don't officially support availability groups across regions. And the other solutions, mirroring, log shipping, some other technologies. So we support between, if you will, within a given Azure region and between on-premises and the cloud. Eventually, we'll remove these limitations as well. These are the high-order bits I want you to remember for limitations, by the way, is what happens to your storage, your computation, and a particular limitation with a SQL solution at the moment. Otherwise, it's quite flexible, to be honest. Okay, guys. I'm going to summarize quickly, and if you have any questions, we can answer them. I gave you Ganesh and I gave you basically a big picture of HA and DR, and using Azure as your DR site, either for your on-premise to the cloud or vice versa. The technologies you would use, here's a list of them here. You have ability sets to make your VM resilient in the cloud. You have Azure Virtual Network to configure hybrid scenarios between one location and the other. You have a number of technologies built-in functions in Azure storage for durability, high availability, and disaster tolerance between remote sites. The actual disk drives, the VM disks that you use in your VMs, are actually stored as blobs in storage. So all the properties of storage applies to your VM disks as well. We now have, with infrastructure as service, SQL 2012 availability groups, always on, number of scenarios all of a sudden open up for all of us. Store Simple is an option you have. It's a very powerful option and a very easy to use option to extend your storage on-premise to the cloud, to do disaster recovery, backup, restore, also scenarios like that. If you have a lot of Windows Server systems you want to back up, System Center Data Protection Manager will enable you to manage your backup system and your restore system from all your Windows Server system to Windows Azure. And all you need, frankly, is a bunch of storage accounts, and you go from there. Everything I told you, well, virtually everything I told you can be scripted using PowerShell. We're committed to make it even easier to use PowerShell. We love the portal, guys, don't get me wrong. It's very nice, especially for monitoring and the like. But some heavy-duty stuff, you want to go script. And finally, we have partnership with third parties. You saw a demo with F5. We have worked with Dryscale. We have many others done, are in the pipeline. That's important. If you have feedback on which partners you need us to work closer with, we'll be happy to take it. And you'll see us doing more and more to open up all these APIs to make sure that you and our partners can work together on the system. That's basically it, guys. We're almost a bit early. So if you have any questions, Ganesh and I will be here. Otherwise, thank you for making up so early in the morning. Thanks, guys.